Hello, I'm David Osborn. I'm from the Media Arts and Digital Technologies Department at the Alberta College of Art and Design.
Hi, my name is Helen Ai He, and I'm from the University of Calgary Computer Science Department.
Explorer is the result of a year-long interdisciplinary collaboration between our two institutions.
A computer simulation of a naturalistic dream world, it is a space for creativity and exploration. A visually immersive experience, it required the application of various real-time rendering techniques. To supplement the standard surrealistic appearance, non-photorealistic textures were created, providing more artistic styles of representation. The user takes on the role of an explorer, isolated within an infinite and self-contained world. Inspired by nature, but free from the constraints of reality, it is both a canvas for creative expression and a hidden alcove of escape and solace.
There are a number of different rendering styles in Explorer, from realistic to hand-painted. It is easy to add new ones. Here are some examples. These textures were drawn with pastels, scanned into the computer, and inserted into the software. This is what they look like in the simulation. These textures were hand-painted with Chinese ink. The high contrast and selective palette creates a dramatic style reminiscent of film noir. These textures were derived from photographs and digitally manipulated to create the desired atmosphere. They yield a more realistic representation of the visual space. Explorer was written in C++ with the help of a number of libraries. SDL provided a cross-platform layer for interacting with the operating system. OpenGL provided hardware-accelerated 3D rendering support. Glue, the OpenGL extension wrangler, was used to gain easy access to extended OpenGL features. SDL Mixer allowed us to load and play multiple sound clips at once. libpng was used to load PNG image files.
Explorer uses a standard human-computer interface popularized by first-person video games. Conceptually, there are two directional input devices, one controlling the camera's locomotion, the other controlling its direction. We implemented support for standard keyboard, mouse, and joystick input devices, with each device mapped to either locomotive or directional control. The keyboard also provides access to special functions. The N key toggles the display of height-map normal vectors. C toggles the rendering of cloud shadows on the ground. L toggles directional lighting from the sun. R toggles the rendering of precipitation. Gravity can be toggled using the F key. The numeric keys control the speed of the simulation. The current rendering style can be switched using the plus and minus keys. When the simulation does not receive any user input for 30 seconds, it enters an autopilot mode. Here, the camera is directed by random impulses, filtered through a set of simple rules to give the appearance of intelligent control. As soon as an input event is detected, the autopilot shuts off and control is returned to the user.
The terrain is represented using a textured height map. As the camera moves through the world, a cache representing the visible terrain is adaptively updated using Perlin noise. Additional attributes are attached to each node of the height map to represent associated features such as terrain texture blending, height map normal vectors, and grass coverage and coloration. Clumps of grass are rendered as flat surfaces sticking up from the ground, with a partially transparent texture. These surfaces are vertically subdivided and animated to bend back and forth, creating the illusion of grass swaying in the wind. Distant terrain is obscured by colored fog, reducing the computational burden and suggesting a dreamy atmosphere.
The sky is represented as a series of concentric domes. The domes are rendered in layers using the painter's algorithm. The outer dome represents the atmosphere and is mapped with a color gradient from the azimuth to the zenith. While often brighter towards the horizon, its exact coloring depends on the time of day. For instance, during sunset or sunrise, there is a distinct red shift due to atmospheric scattering. The second layer represents the occlusive effect of fog on the horizon line. The dome is colored to match the fog at the azimuth, quickly fading into transparency and allowing the atmosphere to show through. Clouds are rendered using a layered set of textures, combined and mapped onto an inner dome. The textures are generated on initialization using Perlin noise. The texture coordinates are shifted over time, each layer moving at a different speed. During rendering, the textures pass through a fragment shader, which scales and clamps their combined value. The result is a single cloud layer, which appears to mutate as the underlying layers shift against one another. The clouds are also projected onto the terrain to create shadows.
Stars are rendered behind the clouds as small point sprites. Each star has an associated color. To simulate twinkling, these colors are rotated between the stars. The sun, or moon, is drawn as a cluster of particles orbiting a center point. As these particles move, the sun appears to wobble slightly, simulating the dissipation of heat. Over time, the sun orbits the simulation space, following a horizontal path around the camera to ensure that it remains visible. Precipitation, such as rain or snow, is rendered using concentric axis-aligned planes mapped with a partially transparent texture. The planes form a vertical grid localized around the camera, with enough depth to represent raindrops within a distance of a few meters. The texture contains a visual representation of a mass of falling raindrops projected onto a two-dimensional surface. The texture coordinates continually scroll downward, creating the illusion of falling precipitation.
Our interdisciplinary collaboration resulted in 2 exhibitions at the Alberta College of Art and Design, once for the Mad Tea Festival and a final showing at the graduation show. In conclusion, our collaboration between art and science was a successful and enriching experience, and definitely one that we hope to pursue more in the future.